Hello, and welcome to this Nutanix Carbon tutorial. My name is Jose Gomez, DevOps Solution Architect at Nutanix. In this tutorial, I'll show you how to do disaster recovery for containerized applications in Nutanix Carbon. Let's get started. This is Prism Central, where I have two clusters, the primary cluster and the DR cluster. On the primary cluster, you can see that it's registered with Prism Central, and we can see as well the IP address for the cluster IP as well as the data service IP. The same for the DR cluster, registered on Prism Central and with the different IP addresses for the cluster and the data service IP. Let's create the storage containers. On the primary cluster, click at Home, Storage, and let's create a storage container for Nutanix Carbon. Click on a storage container, provide a name, carbon-dr in my case, and click Save. Let's repeat the same process on the second cluster, on the DR cluster. Home, Storage, Storage Container, and give the same name. Click Save. The next step is to create the remote site to replicate the data from the primary to the DR site. Click Home, Data Protection, Remote Site, and click to add a remote site physical cluster. Provide a name. Let's get the DR cluster IP. And paste the value on the remote site. Click Add Site. And the next step is to map the storage containers that we created on the primary site and DR site. Click Save, and let's repeat the process for the DR cluster. Click the menu, Data Protection, Add Remote Site Physical Cluster. The name will be the primary site. Go to the primary cluster to get the cluster IP. Copy the value and paste the value on the addresses. Click Add Site and repeat the same process for the storage container. Click Save. Now our remote site has been configured. Let's go to the next step, create Kubernetes storage classes. We have already two Kubernetes clusters, one on the primary site, another on the DR site. You can see my Kubernetes clusters with 3 nodes each. Let's create the storage class on the primary cluster. Click the cluster, click Storage Classes, create storage class. Provide a name, in my case DR, select the right Nutanix cluster, credentials to connect to the data service IP, make sure to select the right storage container, the Carbon DR, and the policy to retain. Click Create. Now we have a new storage class to use the Carbon DR storage container. Let's repeat the same process but using the CLI. I'm going to create a directory to keep everything under that folder. Let's check first that we have the storage class created in the primary cluster. Now we want to create the storage class on the DR cluster. Let's use as a template the default storage class. We are going to export the default storage class and save that on a file that we will modify with the right values. Get the storage class, default storage class, and the output in a YAML file. And we'll save that output on a file called dr-storageclass.yaml. I'm using Visual Studio Code. I'm going to open the folder where we will keep all our files for this tutorial. Let's clean up the template of the keys that we don't need. for example, annotations, creation timestamp, resource version, self-link, and UID, leaving the metadata just with the name. Now that the template is clean, let's replace the values. The name of this storage class will be dr. Let's change the description to dr-storage class. Change the storage container to carbon-dr. And finally, the reclaim policy to retain. Now the template is ready to create the storage class dr. Let's apply the file kubectl apply -f and the file name dr storage class.yaml. The storage class has been successfully created. Let's list the storage classes in the dr cluster to confirm that we have both storage classes. There we can see the dr storage class. I'm going to double check that Carbon is also able to see the dr storage class in the UI. There we have the dr storage class. Let's move to the next step, deploy containerized WordPress application. On the top of the screen is my primary cluster. I'm going to create a dedicated namespace for this application. kubectl create namespace WordPress. The next step is to create the credential for the MySQL database. Now we are ready to apply the manifest files for the WordPress application. Those files will be available in the Kubernetes website. Just making a quick search, we can get the links. We want to download the MySQL manifest file as well as the WordPress manifest files. We scroll down to MySQL and let's save the link. We need to download the files because we need to include the new storage class. If we didn't and apply directly the files in your Kubernetes cluster, the persistent volume claims will be created on the default storage class. That is the class as default on your Kubernetes cluster. We want to make sure that the persistent volume claims are created in the dr storage class that will map the Carbon dr storage container. Once we have both files, we will edit them in Visual Studio. Let's start with the MySQL deployment file, and we will move to the persistent volume claim section. After spec, let's add storage class name dr. Let's repeat the process for the WordPress deployment file. Move to the persistent volume claim, under spec, storage class name, dr. We are ready to apply these manifest files. kubectl -n WordPress for the namespace WordPress, apply -f MySQL deployment -f WordPress deployment. As we can see, all the objects has been created. Let's have a look to all of them. kubectl -n WordPress get all. Pods are being created, and we can see as well the different services. Let's check the persistent volume claims. kubectl-n WordPress get PVC. We can see that they have been created with the persistent volume on the right storage class, dr. I'm gonna check in the primary cluster that we have both volume groups. Click the menu, Storage, Table, Volume Group, and we can see both volume groups. Let's confirm that we can connect to the WordPress application. For that, I'm going to redirect the port to my computer. kubectl-n WordPress, port forward, the service name, the port 8080 my computer to the port 80 in the WordPress container. Open a tab and type localhost 8080. We can see the installation page. Let's complete the details and create a post to confirm that when we run the dr, that post is still there. With this WordPress application, we have two persistent volumes. One persistent volume for the MySQL database, another persistent volume for the WordPress installation. The post is created, Carbon dr post. On this way, we can check when we do the dr that the data is there. The next step is to create a protection domain with an RPO of 15 minutes. On the primary cluster, click the menu, Data Protection. Make sure to move to Async dr. Click Add Protection Domain. Async dr. The name for this protection domain will be Kubernetes-WordPress. We need to add the entities, the persistent volume claims. We can get that information from Kubernetes. kubectl-n WordPress get PVCs. You can see the volume names. We will use them to search in the primary cluster. Search for that persistent volume, select, repeat the process for the second persistent volume. Select the second persistent volume and add them to the protected entities. Click Next, and let's configure the schedule. Let's repeat every 15 minutes RPO. And the retention policy will replicate to the dr side and keep the data for 1 day. Click Create the Schedule. Now the protection domain job is created. Let's wait until the replication starts. Click on the protection domain. The schedule is about to start in 2 minutes. Click Local Snapshot to monitor the process. If you don't want to wait the 2 minutes, you can click on Take a Snapshot. Now the snapshot has been created locally, and let's check the remote snapshots. The snapshot exists also in the dr side. Let's double check. On the dr cluster, go to Data Protection, Async dr. We can see that the job is also there. And if we click on Local Snapshot, we can see that that snapshot is. Next step is create Kubernetes manifest for dr persistent volumes. The following command export the persistent volume manifest into the WordPress primary PV YAML file. Let's check the file. Click on WordPress primary PV YAML file. Let's repeat the same process than before. Let's remove the not required information, annotation, self-link, resource version, leaving the metadata only with the name. Remove UID, resource version from the claim ref. At the bottom, remove the status and repeat the same process on the next part of the manifest file. Remove finalizers, creation timestamp, annotations, UID, self-link, resource version, leaving the metadata, again, only with the name. At the bottom of the file, we will clean up as well the self-link and resource version for the item list. Save the template, and this template is ready to be copied for the DR site and modify the required values. Create a copy of the template for the persistent volumes. Let's move to the next step, simulate site failure. On the primary cluster, go to data protection, click the protection domain Kubernetes WordPress, and select migrate. Select the DR site and type migrate. Click migrate. During this process, the persistent volumes on the primary site are moved to the DR site. But first, a snapshot will happen on the primary site and replicate to the DR site to make sure that the DR site has the latest data. In about 2 minutes, you will get the persistent volumes on your DR site. But Kubernetes is not aware of them yet. For that, we will use the template that we created before. If we check on the primary site, the pods, they will continue running, but the data is not there anymore. If we try to refresh the website will time out. Let's forward the port and check the website. You can see at the bottom that it's waiting for localhost. The application is not running on the primary site anymore. Next step, recovering Kubernetes persistent volumes in the DR site. We need to make sure that we mount the right volume groups. On the Kubernetes DR context, let's get the volumes. For now, only 2 volumes are available, the default ones. We want to mount the DR volumes. But for that, we need to update the values on our DR template, starting for the CSI provisioning secret name. On the DR cluster, the secret is different. Let's copy the following value and replace that value on the DR template. We need to change all the occurrence on that file. Highlight the secret, change all the occurrences, and paste the value that you have on your clipboard. The occurrences has been changed for both volumes. The next value to modify is the cluster target, the data service endpoint. The data service IPs are different between the primary cluster and the DR cluster. Let's copy the value and let's replace the value on the template. Again, change all occurrences. Now we have the new target, pointing to the right data service IP in the DR cluster. The next value to modify is the CSI provisioner identity. Copy the value, and we need to change as well all the occurrences. The next value to update is the IQN. For that, let's copy the value of the persistent volume name for the MySQL. On the DR cluster, search for that volume group. Select the volume and copy the value for target IQN prefix. Replace the value only on the first persistent volume. Make sure you leave the suffix TGT0. Let's repeat the process for the second persistent volume. Copy the name for the WordPress persistent volume. Move to the DR cluster. Search for that volume group. And copy the IQN value. IQNs change all the time when you test the migration. This is a common process that you will have to follow if you test your migration plan. Now the IQNs have been updated. We have still one value to update. That is the volume handle. From the IQN, copy only the unique ID and replace the value on the volume handle, leaving the prefix Nutanix volumes. Repeat the same process for the second persistent volume. Copy only the unique ID of the IQN and replace the value on the volume handle. Now our file is ready to be applied on the DR site. On future, you just need to change the IQN and the volume handles for the same application if you test your migration. To apply the file on the DR Kubernetes cluster, kubectl apply -f and the WordPress DR PV file. The persistent volumes have been created. Let's check them. kubectl get PV. Now we have both volumes, but they are not mounted on the application yet. They are available for the WordPress PV claim and the MySQL PV claims that are the persistent volume claims for the application. Next step, starting WordPress application DR site. Let's create the namespace on the DR site. kubectl create namespace WordPress, as well as the secret, like we did on the primary site. On that namespace, we don't have anything yet. For that, we need to apply the files. kubectl -n WordPress apply -f the MySQL deployment and the WordPress deployment, exactly the same files that we apply on the primary site. With this, all the objects will be created, and the persistent volume claims will mount the existing persistent volumes on the DR site. You can see the pods are being created, and let's check the persistent volume claims if they are bound to the existing persistent volumes. kubectl get PV. Now you can see that they are bounded to the persistent volume claims. Let's check the pods. They are now running. We need to check the website. For that, we will forward the pods into our computer. Let's go back to the website and refresh the page to localhost 8080. Our WordPress application has been successfully DR'd to the second site. Carbon DR post is there like we created on the primary site. Let's create a new post and let's test the failback. Now the process will be more simple because we just need to change the IQNs. We have the failback post to test one we failback to the primary site. Next step, failback to primary site. On the DR cluster, click Data Protection. The protection domain is active, as you can see on the left with the green dot. On the primary side, go to Storage, Volume Groups. We have missing the persistent volumes because they have been moved to the DR side. This is from the Nutanix cluster point of view, but Kubernetes still think that the volumes are there. We need to make sure that we remove that information from Kubernetes on the primary side. If we check the pods, we can see that they are crashing. First, let's change the number of replicas to 0, so we are able to remove the persistent volume claims. We don't have any pod running, and the WordPress MySQL is terminating. We are in the position to delete the persistent volume claims. If you try before, you could get no resource found. That's fine. That will depend on your setup. Now the volumes has been released. We are in the position to remove that data from Kubernetes. There are not volumes to remove on the primary side because they are not there. We are just deleting that metadata, that information from the primary Kubernetes cluster. Provide both persistent volume names. And now the Kubernetes cluster on the primary side is ready for the failback. Go to the DR cluster and click Migrate for the protection domain Kubernetes WordPress. Select the primary site, type Migrate, and click Migrate. This is the same process. The persistent volume will take another snapshot on the DR side and send that snapshot with the delta information to the primary site. We should see the persistent volume claims. There they are. The next step is to mount those volumes in Kubernetes on the primary site. The template that we already had, the only keys to change are the IQNs. The persistent volume names, they remain the same. Let's search for the new IQN. Copy the persistent volume name and search on the primary cluster for them. Copy the new IQN and replace the value on the template. Remember, we need to update as well the volume handle. Copy the unique ID and replace them on the volume handle for that specific persistent volume. Repeat the process with the second persistent volume. Copy the persistent volume name, search for it on the primary cluster, copy the IQN and replace the value on the manifest file. Every time you want to test your failover plan, you will have to repeat this process with the IQNs and the volume handle. The file is ready. Let's apply the file on the primary Kubernetes cluster. We have only 2 persistent volume. Once we apply the manifest, there will be 4 persistent volumes. 2 of them will not be bound yet. You can see they are available. There are not pods because we set the replicas to 0. There are not persistent volume claims because we delete them. Let's apply the same manifest file for the MySQL and WordPress. Those manifest files will create the application. If there are objects that they are already running, they are not going to be updated. The persistent volume claims has been created and bounded to the persistent volumes. But we don't have any pod yet. And the reason is because there are already the deployment on the Kubernetes cluster. We need to change the replicas from 0 to 1. If we check the pods, they are now creating. Let's watch the process. The WordPress is already up and running, and now the WordPress MySQL as well. Let's check the website. First, you need to forward the port. Remember, you need to cancel the other forwarding that you had for the DR site, because if not, the port will clash. Move to your browser and refresh the page. WordPress has been successfully failed over back to the primary site, and we can post, if we want, a new article. I hope that you enjoyed the tutorial. If you want to know more about Nutanix Carbon, please visit nutanix.com/carbon. Thank you for watching.